Hey guys, I kind of messed up on my intro, so here's my intro. My name's Nathaniel. I'm gonna be going over linear equations, systems of linear equations. This is my intro, and then uh, my outro's kind of bad because it cut off my voice, and so you'll just see me doing this. Uh, all right, here's the intro. Thank y'all. So. This is the systems of linear equations. And so we're going to be looking at graphing, substitution, and eliminations of real world uses created by me. Hooray, hooray, hooray. These are just kind of things that we're going to look at here. Sorry, I don't know if that went away. Okay, so what is a system of linear equations? So it's basically two or more equations with the same variable. Solutions equal ordered pairs as in x and y that satisfies all of the equations. An example that we're going to look at later in our slides, so keep this in mind, will be 6 iPads plus 8 MacBooks equals 8,040. And 3 iPads plus 5 MacBooks equals 4,770. And so how we would put that is we're going to have our iPads as x's and our MacBooks as y's. So how we would put that into an equation is 6x plus 8y equals 8,040. Um, and 3x plus 5y equals 4,770. These are the type of solutions we're going to see throughout our graphing because we do graph. So we're going to see one solution, which is lines that intersect once. And this is going to be a consistent and independent. And we have our infinite solutions, which is lines overlap, and we call this a consistent dependent. Uh, and then our no solutions, which lines are parallel, and these are inconsistent. So this is going to be solving systems by graphing slash substitution method. So it's two in one type of thing. So we got to, so pay attention. I'm just joking. Okay, so our steps we're going to have here are going to be our graph each equation, and we're going to find the intersections. So our example will be x plus 3y equals 8 and 2x minus y equals 9. And so we're going to find the slope, which basically means where our lines are going to be heading, in what direction, if it's going to be a consistent, dependent, no solution type of thing. So we're graphing two different linear equations, and so we're going to take one for example, which is x plus, oh, so this is 1 and this is 2, I'm sorry. So we're going to take 1 for example. We're going to do x plus 3y equals 8, and we got to rewrite that as a slope-intercept form, which is going to be y equals negative 1/3 x plus 8/3, and our slope equals negative 1/3, which is going down to the left. It's going down left to right, and our y-intercept intercepts equals 8/3, which is equivalent to 2.67. And we're going to use our second example, which is 2x minus y equals 9. We rewrite that as a slope as well, which is y equals 2x minus 9. So the slope equals 2. The steep is going up left to the right, up left to the right, and our y-intercept equals negative 9. And that will show this graph to be a consistent and independent. And this is where the lines meet at one point. And how we find this one point, I'm going to show you kind of how it's going to work. So we get our 1 and 2 and we put it side by side. X plus 3y minus 8 and 2x minus y equals 9. And so we're going to try to find x by itself, and you're going to see y here in a second. So we're going to have to subtract negative 3y by itself to get it on the other side of this equal sign. And that will come out to be x equals 8 minus 3y. And now we can take this x and put it into here, into the second example. So it would rewrite as 2, 8, negative 3y minus y equals 9, and we combined combine these two, you know what I'm saying, be 16 minus 6y minus y equals 9. Combine like terms, which comes out to be negative 7y. We subtract this 16 from both sides to get it on the other side, because we're trying to find y here, remember, because this is the only y that we have. And so this will come out to be negative 7 as well. And so now to get y by itself, we have to divide negative 7 to each side. And negative 7 divided by negative 7 is 1, so y equals 1. Now we can take this y and plug it into our first example, y. So now it would be x plus 3 times 1 equals 8. 3 times 1 is 3, and now we can take this 8 and subtract it by 3, which will give us 5. 5 plus 3 times 1 equals 8. So now we have x equals 5 and y equals 1. So that's where our point will be. And so now we're going to go into our elimination method. So this is what we're going to do. We're going to write equations in standard form, and we're going to multiply if needed, and then make the coefficients opposite. Add or subtract equations to cancel a variable, and then solve for the remaining variable, and then back substitute to find the other. So this is what we're going to do. We have 1 and 2 here. 2x minus 3y equals negative 6, and x plus y equals 7. We're going to have to multiply 2 by 3 because we have to find the coefficient of y. And so this will rewrite as 3x plus 3y equals 21. And now we have to add 1 into everything. So we do 2x minus 3y plus 3x plus 3y equals negative 6 plus 21. Now we just add everything up. We add all this, or technically subtract. We do negative 3y plus 3y, which is 0. 2x plus 3x equals 5x. So now we have 5x equals 15. Now we have to get this x by itself. We divide 5 to get x by itself to both sides, and that will come out to be x equals 3. And now we substitute into 2. So now that we have 3, which is our x, 3 plus y equals 7, we can do 7 minus 3, which is 4. So we can just say y is 4 because 4 plus 3 is 7. So the solution is 3, 4. And our point will be 3, 4. And just like how we did on our previous slide, you can find our slope the exact same way, and you can see how these lines would be consistent and independent. We're not going to get into these, so I just kind of want to briefly go over them. Is the inconsistent versus dependent systems. The inconsistent system equals like no solution. So our no solution example will be 3x plus y equals 12, and 6x plus 2y equals 15. So we try the elimination, and then we go to the variable cancel, and we're left with 0 equals 3. And now we have a false statement and it equals no solution. Now the graph is parallel and it never intersects. There's no intersection, it's just parallel. And then our dependent system is an infinite solution. And it would be 5x plus 2y equals 9, and negative 20x minus 8y equals negative 36. This is our example, and we simplify the second equation and divide it by negative 4. And now we take our 5x plus 2y equals 9, same equation, and it's infinite solutions. We graph the lines that they overlap. And this is going to be our real world examples of how we were talking about in the beginning of our MacBooks. So the backstory of this is the manager lost the invoice but had a total cost by setting up two equations. So how we're gonna solve it is a bookstore ordered iPads and MacBooks in two shipments. So 6 iPads plus 8 MacBooks equals 8,040, and 3 iPads plus 5 MacBooks equals 4,770. So our X is the iPads and the Y is the MacBooks as in before. And so we're going to do 1 and 2. So 1 is 6X plus 8Y equals 80, or sorry, 8,040, and our second is 3x plus 5y equals 4,770. So we're going to do everything that we just learned in our last couple slides. So steps to solve, which is going to be our elimination. So we got to multiply the second equation by 2 because we got to find the coefficient. So we got to multiply the second equation by 2, so it'll be 6x plus 10y equals 9,540. Now we subtract from the first equation, which is 6x plus y minus 6x plus 10y equals 8,040 minus 9,540. And now that we have all this, we combined everything. So it'll be 6x minus 6x was 0. 8y plus 10y is 18, I believe. But we get 2y. Oh, because it's a negative. Because we have to subtract. That's right. So we get negative 2y equals negative 1500. So we have to divide it by negative 2 to find y. And so two negatives equal a positive, and that comes out to be y equals 750. And so our y is 750 MacBooks, 150 dollars. And so number 3, to find x, is we substitute it back. So it would be 3x plus 5 times 750 equals the 4,770, and this will come out to be 3,750. We got to subtract that from both sides, which will give us 1,020. We divide that by 3 to each side to get x by itself, and x equals $340. So the solution is iPads equals 340 and MacBooks equals 750. And so this shows how algebra can help solve real world problems. This will be the end of my closing, and these are the key takeaways that I got from making this presentation. If you guys have any questions, please let me know, and I'll try to answer it to my best of my knowledge. And thank you for listening to this podcast. Thank y'all for